and welcome to lecture 9 of the module Reason and Persuasion. This week we're going to continue the theme we started last week. That's the psychology of decision making, and in particular the psychology of mindless decision making, or to put it another way, the psychology of system 1 decision making. So that's a reference to the idea that really there are two ways that your brain goes about making decisions. There's system 1, which is quick, what you might think of as quick and dirty thinking, following rough and ready rules, which gives you very quick, efficient results. And the system 2, which is where you think things out slowly, carefully, slow analysis, right? Okay, and that distinction comes from a book on fast and slow thinking by Daniel Kahneman, which is based on research that he did with Amos Tversky and others. Their research essentially was a challenge to the idea of economic man. So economic man is the model that is classically used in economics. So the assumptions of classical economics is that firms seek to maximize profit, and households and the individuals that live in them seek to maximize something called utility or satisfaction. Whatever it is that we're trying to get out of our economic activities, and if you're an economist, more or less everything is an economic activity. That's satisfaction or utility. We're trying to maximize it. So what you do, if you're doing classical economics, is you assume that people are rational in their pursuit of profit in the case of firms, and utility or satisfaction in the case of households and individuals. What does that mean? It means you assume that they're good at making the necessary calculations. And then you make the same calculations, and that will allow you to predict what the firm or the household or the individual will do. Now that's in a way a nice simple model, but it does assume that firms and households and individuals are calculating. And not just calculating in their attitudes, but effective calculators. Now, for large firms, this may be true because they employ people to do analysis, and they have big computers, and they do figure things out slowly and carefully. But small firms and households and individuals are guided by the judgments of individual people. And we're not very good at sums. We're not logic engines. And that's what Tversky and his Kahneman and his colleagues discovered. But they put numbers on it. So they did some experiments. They put some science on it. Okay, so that really is what we're doing. Last week we had kind of Cialdini's six weapons of persuasion. Now we're looking at this kind of Kahneman-Tversky stuff. Okay, so before we get into it, I want to give you a principle which you should bear in mind, which is that the aim of propaganda is to change behavior, right? What the propagandist cares about is what you do. They don't really care what you think or believe or feel, except insofar as that allows them to manipulate what you do, right? And that's important because, for example, in an election, people might vote for individual reasons. There'll be lots of different reasons why they vote, but they may only have 2 or 3 voting options, right? So it's the outcomes that matter, it's the behavior that matters. And if you can drive people's feelings, their fears, their hopes, their sense of self, their identity, that kind of stuff, that tends to come in much bigger lumps and is easier to manipulate than people's thoughts. Okay, so the propagandist is trying to get you to change your behavior, to act differently. And they're only indirectly interested in what you think. For example, shopping, voting, choosing media, television programs, whatever, and of course your higher education choices, your choice of courses and modules. These are all things where somebody has an interest in guiding your choice. And the way that they guide your choice is by offering you heuristics, right? So to set up what a heuristic is, I first of all want to set up a contrast. Think about a classic physics question about dropping a ball from a stationary position, and it falls through a known height, and you want to know how long it takes to fall through that height, right? So if you know the initial velocity is 0, you know the height, you know that the ball is dense enough that air resistance doesn't really matter, and you know the constant of gravity. That gives you all the information you need, and what's more, you know, if you were listening in school, you know the 3 Newtonian equations for motion, and also, helpfully, they are very simple equations. They don't involve a lot of computing power. So you have these 3 elements in place. You have all the necessary information. You know what the equations are, or the analytical process is to work the thing out. And what's more, you have enough computing power, right? Because the computation that you have to do isn't very big. It doesn't require a supercomputer. You can do it with your brain and a pencil and paper. But this isn't typically the case, right? So if you think about something like buying insurance for some distant risk. So if you're a young person, you might be invited to buy insurance that will last you a lifetime. So you're being invited to think about the likelihood that you might become too ill to work in 3 or 4 decades' time, right? How at the age of 19 or 25 are you supposed to think about that? You don't have the information that you have for the textbook physics problem. You don't have all the facts, because there'll be features of your health that you don't know about because you haven't been tested for them yet. You may not know what diseases you're susceptible to until they start to show themselves in you. Possibly, I mean, there may be some things to do with your DNA, but let's assume you can't be tested for everything. So you don't have all of the facts, unless you have had very special training in actuarial science. You probably don't have the necessary equations, right? You probably don't have the analytical tools necessary to work out how likely you are to fall ill in this way but not that way at some point 3 or 4 decades in the future. And what's more, you probably don't have the computing power, because these are big sums, right? You need a big computer to do that calculation. So you couldn't, even if you wanted to, even if you say, right, I'm going to be really rational in the way I buy insurance. I'm going to buy insurance rationally. Okay, where are the facts? What's the necessary equation? How much computing power do I need? The answers are, you don't have all the facts. You don't have the training necessary to understand the equations, and you don't have a big enough computer anyway. Okay, you still have to buy insurance. How do you do it? Well, you use a rough and ready rule. You use a heuristic, right? So you may, for buying insurance, just assume that you're going to be susceptible to the same diseases as your parents, right? Or you assume that you're susceptible to the same sorts of diseases as other people in your part of the world of your sort of age or something, right? I mean, you grab some rule like that, and that probably won't take you far wrong. Or if you think about the weather, okay, you're going out tomorrow. Well, what's the weather going to be like in the place where you're going to be outdoors? You could try to build a model of the climate in your area. You could try to model the movements of air and water vapor and all the rest of it to figure out whether it's going to rain in the place. And this is, again, you probably don't have all the facts unless you have access to the Met Office data sets. You probably don't have the necessary mathematical models, again, unless you're in the Met Office. And you definitely don't have a big enough computer, right? So using the system 2 route, working the thing out analytically, is not open to you. So you use a heuristic. And the best heuristic for deciding what the weather's going to be like tomorrow is just to assume that it's going to be the same as today. That's really accurate, actually. I mean, of course, it lets you down sometimes. Otherwise, the weather would never change. But it's the computational overhead, the amount of computational power you need is almost nil. The base of information you need is pretty slim, and you already have it because you know what the weather is like today. And it gives you a very high level of accuracy. So that's a great heuristic. And one of the things about heuristics, one of the ways in which people often misunderstand them, is it's not always about speed, right? So one of the things about heuristics is they give you quick decisions, and quick is good, and very often quick is what you want. So for example, following the crowd, speed may be important because the crowd may be running away from an emergency or a threat. And following the crowd gives you a quick decision, and that gets you away from the tiger or the falling building or whatever it is. So sometimes speed is the valuable feature, but not always, right? Sometimes we use heuristics because we don't have the information, or we don't have the computing power, or we don't know what the mathematical model is. Okay. So now you have an idea what a heuristic is. Try and draw on existing knowledge. Think of a few examples. Do that exercise, and then I'll give you a few examples of my own and from the textbook.